Hi, my name is Adrian, and this video demonstrates my RichWeb Applications CA2 assignment. The application is a client-side memory card game built using web components, Vite, Firestore, Jest, and GitHub Actions. I'll demonstrate the application's functionality, persistence using Firestore, automated testing, CI/CD deployment, and discuss problems encountered during the development of the app. So this is my GitHub Classroom development repository. The commit history here I will be showing you across all the stages of the assignments rather than just the one single large commit. So here's my commit messages on both branches, on my main and master, as I tried to push my code into the main repository or the main branch, but I just couldn't get it to work for some reason. But here's my commits anyway. So here's when I added the Jest configurations. Firebase configurations. On the main branch, initialized npm project and installed Vite for stage 2. Fixed a bit of the styling and the card changes to kind of make the app unique more to myself. I built the board, created a single instance for the game element, removed the starter code practice that I was using for the assignment, and then added the starter code files from the zip, as I was practicing how I would do this by myself before using any of the starter code. Created the styles and the first initial commit of the project. So this is the core of the assignment. This is the memory card game implemented as a custom web component called a memory game. The board size is configured using a single attribute in formatted rows by columns. For example, this 3x4 grid I have here, and there's two cards being clicked there until I find a matching piece. There. So the game uses provided shape cards from star code component, which wasn't modified as required by the brief of the subject. So the cards flip on click, matched pairs remain face up, and the unmatched cards flip backwards after a delay. Just like that. And then cards matching. So the game logic ensures that only 2 cards can be active at a time, and it prevents that already matched cards from being selected again. Now to show my Firestore integration, so firstly we'll complete the game here. And as you can see, it shows you that you finished it in 15 moves. And also right here, you can click to show the average clicks you have from the last games you've had. So once the game is completed, a result is stored in Firestore collection called game results, and each document contains the number of clicks taken to complete the game and a server generated timestamp of when it was done. So as for this recent one, here's my Firebase console and a list of all the most recent clicks stored. And here is our one here. So it took 15 moves and 30 clicks to complete, and was completed right now on the 14th of December 2025 at 4:48 p.m. So this satisfies the requirement to store timestamp game results in Firestore. So just to come back to the show average clicks, now that there's completed, it updated here to 26.29. So the application calculates the average number of clicks required to complete the game, and the value is then computed by reading all stored game results from the Firestore, and then is calculated using the mean. Now for stage 4, it was automated unit testing, and it was implemented using Jest. 2 distinct unit tests verified the core logic such as the board size, parsing, and card matching. So I'll be showing you the workflow. So as you can see, the tests were all ran successfully, no issues in the build and deploy. Same with the install and test. These tests also run locally using npm tests, so here I'll do that in my terminal. And as you can see, the tests passed for the both of them. And they are also executed automatically as part of the CI pipeline. So going back to the GitHub Actions workflow overview, a CI/CD pipeline was configured using GitHub Actions. On every push to the main branch and master branch, the pipeline installed dependencies, ran unit tests, built the application using Vite, and was deployed through GitHub pages. And deployment could only occur if the tests pass successfully. So here is my pipeline and its tests. Here's the build and deploy, coming back to them. As for problems that I was encountering and solutions I came up with, one issue I encountered was configuring Vite for GitHub pages, and I ended up using the incorrect base path, and it caused the deployed site to appear blank. So what I did to resolve it was correctly setting the base option and routing the file configurations properly into the Vite configuration file. Another challenge that involved configuring Jest to work with the ES modules. This required me to add additional configurations so that tests could run both locally and in the CI, both in package.json and the packagelock.json. And as for another problem that I encountered is that care was required to ensure the Firebase writes, the Firestore writes occurred only once per completed game. So, which was solved by triggering the write only when all pairs were matched. So in memorygame.js and the async check pair and code structure. As for audit testing, this was performed in Google using the browser development tools in Lighthouse to test performance, accessibility, the best practice, and the SEO of the project, to ensure that the semantic was structured and readable and had a readable contrast. So here's the test being performed. And as you can see, I got a high score in everything after completing the test. So this concludes the demonstration of my CA2 assignment. Thank you for listening.